morning, AP Chem class. Today I came back over to school. I wanted to run a quick demo and to show you how to do the calculations for titrations. So first thing I want to do is I want to just show you what happens when I put some base. This particular base is going to be at 0.012 concentration, and I'm going to add an indicator. And this indicator is the indicator that we like to use in chemistry. It's phenolphthalein. Phenolphthalein has a very distinct color change. It's very, very clear, but once it reaches a pH of about 10, it will go to what we call shock pink. So I'm going to put one drop in here, and you can see that, yes, it went to a very, very deep pink. So the reason that we like to use this particular indicator is it's hard to miss. You can really, really tell whenever you're at the point. So let me go through and I'm going to set up a titration for you. A titration is used to determine what an unknown concentration of an acid or a base is. We're going to start with our stock solution. Our stock solution is magnesium hydroxide, and it's going to be at a 0.012 molarity. So you put your stock solution, what you know, into your burette. So I'm going to slowly fill up my burette, and I'm not going to fill it all the way full. I'm going to stop right there, and I'm going to determine what is the actual volume that I'm starting with. So I am starting with a 1.75 milliliters. So I'm starting with 1.75 milliliters. So I'm going to, I put it in the wrong spot. Let me come back over here. 1.75 milliliters. Now I'm going to place a known amount, and I'm going to measure this using a graduated cylinder. This is going to be of my HCl, but I don't know what the actual concentration is. So that's what I'm going to be trying to find. So I'm going to start with this one, and I have 30, and then that's going to be 31, 32, 32.8 milliliters. So I'm going to start with 32.8 milliliters of the acid. So I need to place my acid into, here we go, into an Erlenmeyer flask. And then what I'll do is I'm going to place this underneath my burette. Get it situated. Now, big thing is, definitely don't want to forget to add our phenolphthalein. So I'm going to put a drop or two in there. I actually put quite a bit in there because it ran down the side. But you notice that it's no color change. So if there's no color change, that means that the pH is going to be below 10. So what I'm going to do is I'm going to start putting some of the base into this, and you can see that it's slowly changing into kind of a pink color. Now once it starts to change a little bit more, yeah, you can see that I add some and then it changes back, add some. Ooh, we're getting closer. So now I want to slow it down just a little bit, so you can see that I'm going drop by drop. Now I'm stirring it ever so gently so that my color will end up holding. Now right in there. It's going away, so I'm going to keep going. Alright, so I'm getting a little bit closer. So I'm going to slow it down to drop by drop. Very tedious work because it starts off and then it starts slowing down, and then you never know exactly. Right there. Nope, not quite. And there we go. So we got a color change. It has a little bit deeper than I'd originally liked, but it now is completed. So when its color changes and holds, you're through. So I'm gonna measure my final, which is 27.64. So down here, I'm gonna put 27.64 milliliters. So by knowing how much I started with and what I ended up with, I can just simply say 27.64 minus 1.75. That'll tell me how much I actually used. So that'll give me an 8. So I used a total of 25.89 milliliters. All right, so this, I'm through with the titration, but now I have to do the math part of it. So I come over here and I have two equations on the board. And if you look, it says dilution. This is the one that we've used before. M1V1 equals M2V2. So we've already used this one. And then I come over here and I say, well, the titration is exactly the same thing. Well, it's a little bit different. I need to add to it. When we were in honors chemistry, we always had our acids and our bases at a 1-to-1 ratio. This, however, is a little bit different. So I'm going to get H2O plus, and then the salt is MgCl2. So now when I balance this equation, I'm going to put a 2 right here and a 2 right here. So when I look at this, I have not a 1-to-1 ratio with my acid to my base, it's a 2-to-1. So what I have to do is, in all titration problems, you have to look at the number of moles. And that's going to be the coefficient in our balanced equation. So I'm going to come back in now and I'm going to substitute all of my numbers in. My base is going to be the molarity of 0.012. My volume is what I used, 25, but I have to put that into liters, 0.02589 over, and then this case, my base is going to be 1, is going to be equal to the molarity, that's my M2, that's what I'm actually looking for. What is the molarity of the acid? So now I'm going to come back over here and say I started with 32 point, have to change that into liters. I have 0.0328, and then this time it's divided by the number of moles of my acid, which is 2. So now I can just simply do the math and determine the molarity for the acid. So I'm going to go ahead and punch that in real quick. And 0.012 times 0.02589 times 2. And we'll divide all of that by 0.0328. So I get from my final molarity a 0.0189 molar. So what I was able to do is very simply take an experimental data here, plug it into the formula for titration, taking into account the balanced equation up here to get the final molarity. Now I noticed that on some of your homework papers, when y'all were doing the neutralization, y'all did not take into account this number of moles right here. So if you didn't do that, or you haven't quite got to that last assignment on acids and bases, make sure that you use this formula. So I hope this has been helpful, and remember, phenolphthalein is the indicator that we usually use because it turns such a pretty pink color. Thank you.